Good morning, everyone. Nice that so many people made it after this hard party yesterday. My name is Michael Riffley. I'm living and working in Switzerland for a company called ITnetics. We are an ISV specialized on cloud infrastructure. Me personally, I'm MVP for a cloud and data center, mostly working for service providers, and therefore I'm going to talk a little bit about software-defined data centers today. We're going to scratch the surface, a little bit how software-defined data centers look, what we have to consider if we want to do everything software-defined, the pitfalls, and also the organizational aspects beside of the technical funny stuff, what we have to consider there to make it a success at the end. So if you have a look at the traditional data centers, there are some key points. Everyone knows them. We have different hardwares. We have different vendors. We have different solutions for everything which lives in the data center, starting from network, going to storage, going to backup solutions. So each of these solutions brings its own management tools. We have management tools for all the components which live in the data center. So that brings a lot of complexity with it, right? So each tool has its own, let's say, purpose, its own difficulties or functionalities. You have to learn it. They don't really integrate very good usually, and it's mostly managed manually because they don't have standardized interfaces, or a lot of those tools don't have standardized interfaces. So therefore, it's people-centric. You have to have specialized knowledge for each of the components to operate it, to design it properly. And therefore, you have all this specialized people. You have the storage admin, the network admin, the component X admin. And there is a cool statement. From my point of view, this graphical stuff looks nice, but it has a big issue. So if I want to configure something in a graphical interface, I click here, click there, click, clack, look, and at the end I reach my result. But how do I transfer this knowledge to other people's? I have to create tons of print screen documentations or sit beside each other people and show them how to operate in the graphical user interface. In a software-defined data center, this is a huge problem. Because if we want to have a data center which is more like software operated rather than specialized hardware components and the overlaying management tools, we have to automate the stuff. We have to use commodity hardware, meaning hardware which follows standards, like the OMI standard or the WS-MAN standard, whatever you want to have there. We have most of the vendors today are looking into integrating some REST APIs. We want to automate the stuff, so if we do something correct, or either we do something wrong, we do it 10 times wrong or 10 times correct. But as something works, we want to automate this. Not only to free us up from, let's say, not that interesting work, also to have a consistent infrastructure. If you have 2 Hyper-V hosts, for example, to manage, that's not really an issue. If you have hundreds, then you want to have those consistent configuration consistent on all over the hosts. It doesn't stop there, of course. There are a lot of components involved in a data center, not only the Hyper-V hosts. And there is a term like infrastructure as code. You might have heard that already for other purposes. I'm pointing it out here because if you want to configure something in mass, then you have to automate it, as I said. So how we do that? We will talk about that in some minutes, how to achieve this. The fundamentals of a data center are, of course, the network, the storage. We have a compute layer, and we have some management tools and scripts and whatever we want to use there. We have a security layer, which is really important. And we have the automation surrounding all the fundamentals here. So automation is key. I'm coming back to that every time. In large data centers, it doesn't really require you to be a service provider. If you have a large data center, you want to have automation. So the software-defined storage, to be taken as the first component here, you might have seen a session about Storage Space Direct. Storage Space Direct is, let's say, the enhancement of the existing storage spaces solution we have in 2012 or 2012 R2. It's basically the same concept, beside the fact that the storage doesn't have to be shared. So each node has its own local storage. You might know similar concept of vendors like VMware with their vSAN solution or Nutanix. So this is similar. We have storage nodes with local storage, and they see the other nodes' storage over a so-called software storage bus. This is a software component layered on the SMB3 protocol. All the nodes communicate over SMB3 to see each other's node storage disks in the cluster. So because this is built in the operating system, we use standard hardware. Of course, it has to be certified and validated for Storage Space Direct, but we use standard hardware. So the management layer is the operating system, or WMI, or WinRM, or SCVMM, or failover cluster manager, whatever you want to take there. So this is software-defined storage. And if you have a look at the scenarios, just a quick wrap-up for those who did not hear anything about Storage Space Direct. We have two models here. We have a hyperconverged scenario where the compute node is at the same time is also a storage node. So we combine compute and storage power on the same node, meaning each of those 4 storage nodes in this example is also a Hyper-V node within the Hyper-V cluster. Or we go with the converged or disaggregated model, where we have Storage Space Direct nodes in a cluster, and on top of that we have traditionally our Hyper-V clusters connected over SMB3 to the storage layer. Not stopping here, software-defined storage does also mean we need replication. Wherever we want to have multiple data centers, we will at some point in time have the requirement to replicate our data. Either asynchronously using Hyper-V replica on the application layer, or using storage replication. Storage replica has been introduced now with Server 2016. It's a block level synchronous or asynchronous replication. It's hardware agnostic, so it does not really require you to have storage spaces or Storage Space Direct underneath. Any volume type can be used. The volumes can be local or SAN or iSCSI storage, whatever you want to take there. There are different scenarios which are supported. We have a server-to-server configuration, single server to single server, cluster to cluster, or even a stretch cluster within a, let's say, limited amount of a limited distance. That's because of the fact if you want to have a stretch cluster with the synchronous storage replication, the round-trip time of your network infrastructure should be below 5 milliseconds. So that's a golden rule here. This is built in. You have just to enable it, and you have a synchronous or asynchronous storage replication. You choose which volume has to be replicated synchronously or either asynchronously. Again, software-defined. No need for special hardware components here. Another thing you want to consider in a large infrastructure, or if you are a service provider, is how do I mitigate the noisy neighbor problem? So you have 90% of your customers are behaving like they have a good behavior, they do their normal operations. Then you have some certain customers, they want to test you. They want to test you how your infrastructure behaves if they perform a huge load test on the storage. Or they have such typical workloads like OLTP, large transactions, where your storage infrastructure might suffer. So you want to guarantee a certain layer of quality on the storage layer, meaning throughput, IOPS, or latency. Storage quality of service introduces a new way to centrally manage those parameters. I mean, if you have Hyper-V right now, you can limit your VHDX to a certain amount of IOPS per VHDX. Cool enough, but it's not centrally managed, and it's hard to control it. If you have thousands of virtual machines, hundreds of hosts, then this is not really the solution you want to go for. Storage quality of service is controlled by a I/O scheduler living on the storage layer, and then a rate limiter talking to the storage layer, where we have the limitation of the virtual disk files of your virtual machines will be set on the compute layer, but controlled on the storage layer below. So the storage in this situation can be a scale-out file server, but it also can be a Hyper-V cluster with traditional SAN storage. So it doesn't require, again, you to have storage spaces to leverage this particular feature. Short word to these storage QoS policy types. I'm going to show it how this works live in a moment. You have different policies. Either you want to have a policy which aggregates a certain amount of IOPS to all virtual machines you assign the policy to, or you have a policy where you want to guarantee a certain amount of IOPS, maybe in this case to each virtual machine, like Azure does. A lot of people don't know about how Azure does this, but it does it the same exact way. So if you want to have, if you take a standard virtual machine, it's something around 500 IOPS you get out of each virtual disk. This is a limitation Azure gives you. If you want to have more, then you have to buy a virtual machine of a different size with more power. So let's have a look at software-defined storage. What we see here is System Center Virtual Machine Manager 2016. I have two scale-out file servers managed by VMM here, and let's say I need another volume. This volume is only 100 gig. I need more to provide more space for my virtual machines. I can do this with PowerShell, of course, or going back to the antisocial way, I'm showing you how it performs in VMM, because VMM is a tool which is, let's say, it's a GUI, yes, but it's a GUI where you can centrally manage all of your fabric stuff, meaning compute nodes, storage nodes, even network stuff you can manage out of VMM if you have the right plugin from your vendor. So let's create a new volume on the storage space direct cluster here. I can choose the storage pool. I assign a storage classification, which enables me to automatically place new virtual machines as they are created to the right quality of storage. I have to give it a name. Give it the size, 500 gigs. My fault tolerance, how many fails do I tolerate? 2 disks simultaneously failure, I don't lose data, or a whole node and the disk, I don't lose any data. That's my policy here. And I'm going to create this volume using VMM, and we will see afterwards, when the job has finished, that I will get a new volume. It creates all the stuff we need behind the scenes. A new virtual disk on the storage spaces pool, a new volume. It adds the volume to the cluster shared volume of a storage cluster, and it creates a file share on this volume for the later use over SMB3. So the job is done. The only thing I have to do right now is go to my Hyper-V cluster and assign this new volume here to the cluster, so it can be used by the cluster as a placement for new virtual machines. So the next thing I want to show you is the QoS stuff I talked about a minute before. Gonna quickly log in into the virtual machine. What I'm running here is disk speed with a certain parameters, 4K block size, 16 outstanding IOs. Now we have around 30,000. It's going up and down, 30,000 to 50,000 IOPS a second from this virtual machine, with a decent amount of latency. So we're just around 1 below 3 milliseconds within this virtual machine. It's not that bad for this infrastructure I have here, but I have a huge issue. If I have 3 virtual machines of these creating that amount of IOPS, my storage system will be really filled up with IOPS, and maybe other systems will suffer with real workloads. So I want to limit this virtual machine to a certain amount of IOPS. This can be done by PowerShell. So I'm going to show you the way how we do this with PowerShell. First, I'm going to have a look at my storage QoS situation, how it is right now. I execute this command against the cluster, and again here, it's centrally managed. I can see which virtual machine, which virtual hard disk is currently creating all these IOPS. So the bad guy here with the virtual machine Ignite 1 with this particular VHDX is creating 30,000 IOPS. I don't want that. So either I create a new policy, or in this case here, I'm going to grab the policy I've already created on the cluster, just to show you the parameters. I have a demo policy with a limitation of 1,000 IOPS per virtual hard disk. This is a dedicated policy, so each virtual machine hard disk will get a maximum amount of 1,000 IOPS. I'm going to assign this policy to the virtual machine. And we should see the drop down of the IOPS now. Yeah. So this is real time. You assign the policy to the virtual machine, and the IOPS will get limited. Of course, as I am generating 100,000, or I try to generate 100,000 of IOPS right now, the latency goes up because the system is not able to empty the queue in a certain amount of time. That's normal. Again, as it is software defined, I can change this behavior also from Virtual Machine Manager. Because I did it outside of VMM, I'm going to quickly refresh the virtual machine here. So I should see, to this particular VHDX, I have an assignment of this policy. Now I want to change that. I want to give the virtual machine 10,000 IOPS, not only 1,000 IOPS. Again, this is the same process, just using another tool. And we will see the IOPS going up to 10,000 at max, but not more. Software-defined networking, a big stuff. V1, we talk about V1 when we talk about the implementation of 2012 R2, where the network, software-defined networking is primarily defined by network virtualization using NVGRE, the GRE protocol to virtualize our networks in the data center. So the underlying infrastructure here is the same for every technology we use. We have physical hosts, we have physical switches. They might be managed using OMI standards or not. It doesn't matter here. We have the network service layer of 2012 R2 with network load balancing, a multi-tenant gateway for the GRE encapsulated networks, And we have the control layer, we have SCVMM, we have SPF talking to Azure Pack or vice versa. So this is the current implementation we have right now, also implemented within a lot of projects myself. This is currently stable and working. So this is software defined because we don't really care about the underlying infrastructure, the physical switches, the type of physical boxes we have on the compute layer. It doesn't really matter because on top of that we have this software-defined layer. In this implementation, it's GRE. So with 2016, another functionalities are coming up. So we still have the physical layer, of course, but then with this V2 setup of network virtualization, we have another default. So the new default is not GRE, it's VXLAN. We still can use GRE, but the new default is VXLAN, mainly because the ecosystem around VXLAN is bigger than GRE, as it's by now, right? So there are new components being introduced, a software-defined load balancer component and a distributed virtual firewall. You might know this functionality from Azure because it's exactly the same. So they are using those functionalities to create the security, the network security groups. So if you create a network security group on Azure to enable communication between virtual machines or your virtual networks, behind the scenes you have this distributed firewall. So everything is based in the operating system itself. The network controller, those of you who are using Cisco ACI, they also have a network control, but it's specifically to this product. This here is the same type of component, but it's based on Windows Server 2016. So the network controller talks to the underlying stuff. It can talk to physical switches, to manage physical switches, and it also talks to the underlying or the software layer of virtual network functions. In this case here, we have the Azure Pack portal, which can talk to SDN v2 as well. But of course, if you're going to the new platform, Azure Stack, we have the Azure Stack portal or third-party implementations talking to the network controller. We don't need SCVMM, but SCVMM is still an option to talk to network controllers. Or, for example, if you want to deploy network controls automatically, SCVMM helps you there using service templates to scale out your network control infrastructure. The network controller itself has a northbound API, a REST API, and a southbound API to talk to physical switches, for example, or to talk to the network virtual functions like the software load balancer or distributed firewall. It's a scale-out service, so it's basically by default is highly available, and you can scale it out to have it distributed and more available. So now we have the software layer. Let's quickly look at the hardware setup. This was the setup we have to use for 2012 R2, right? So if you want to have software-defined storage with storage spaces, you had to have different network cards for different purposes. In this example, we have 2 network cards for our logical switch or for our Hyper-V switch to enable network connectivity for virtual machines or the management operating system. So for the storage side, we had to have dedicated network cards. Just because of the fact, RDMA, if you're using software-defined storage with storage spaces, it's recommended that you use RDMA cards to lower the latency and to increase the throughput and to lower the CPU consumption on the storage nodes and on the compute nodes as well. So 4 NICs for a typical setup. This is a little bit not that cost effective, of course, because you have the double amount of ports per physical node you need in this configuration. Now, if we have a look at the 2016 way, the switch embedded teaming frees me up from creating a teaming on the operating system level. The teaming mode is now configured on the switch itself. Not only this, the logical switch, or the Hyper-V extensible switch, now supports virtual RDMA. So RDMA NICs can be virtual NICs, as we know it from the management cluster live migration virtual NIC we already had in 2012 R2. Now RDMA is also capable to rely on a virtual NIC. So we only need 2 ports. Of course, recommendation here, at least 10 gigabytes ports. I would go for 40. But with 2 single ports, we can leverage all the functionalities like RDMA for storage traffic or virtual machine traffic or even host management traffic. So in this demonstration, I'm going back to another layer. I'm going to show you software-defined networking from a end-user perspective. What we see here is a Azure Pack implementation. I have some virtual machines. I prepared a virtual web server named Ignite Web 01. I have a virtual network using GRE technology. My virtual machine is mapped to this virtual network. You can see that here. So how do I get access from the outside to this virtual machine, or specifically to this web server? The first thing I do as an end user is to enable network address translation on my virtual network. This is already enabled. You can see that here. So by just enabling this checkbox here, my virtual network gets a connectivity to the outside world using the NVGRE gateway, the multi-tenant gateway. So next step is I have to create network address translation rules. If I want to get insight to the virtual machine from the outside world, I have to create a NAT rule. So I'm going to create that quickly and tell this demo web. This is the public IP address which has automatically been assigned to my virtual network for NATing. I define the source port as port 80 and the destination port as port 80. And I'm going to choose my virtual machine here, Web 01, to create a NAT rule. So the NAT rule has been created. I should be able to contact the web server using this public IP address as long as I don't have a DNS record for this IP address, but it does not work. Because of the fact I'm using the 5.9 extension here, I protected the virtual machine using the virtual firewall of 5.9. So this is a distributed service to my tenants where they can specifically create firewall rules, in and outbound rules themselves on their virtual machines, similar to the way you do it in Azure right now with the network security groups. So what I have to do is going to my virtual machine, create a virtual firewall rule, or just use a template my service provider or my manager already has defined for me. Now I have some example templates here, HTTP inbound traffic, that's what I want to have. Apply this to this virtual machine. And now it's there. So software-defined networking from the end-user perspective. I don't have to deal with physical cables, VLANs, ask the network, can you define me another VLAN? I want to have another IP space. I need another firewall rule. This is all self-control. If you want to have that, of course. So let's talking about the host security. Also a software-defined component, which is really important because the problem we have right now, especially with service providers, they are not able to protect themselves from their administrators. So as long as you don't have access, as long as you have access to the Hyper-V host or the virtualization host, you're God, right? You can control the virtual machines, you can export them, you can mount the virtual disk files. There's no protection from your service provider admins in terms of, or let's say from the perspective of the end user or the customer. So this is a huge issue. So 2016 server introduces new functionalities like the host guardian service, the virtual secure mode. I'm not going too deep in this at this topic, but we can secure the virtual machines using virtual TPM. So now we have the ability to have a virtual TPM chip assigned to the virtual machine, making it possible to encrypt the VHDX by default using BitLocker, or use the host guardian service to define a certain amount of hosts which I trust from a customer perspective. So I can decide, yes, this is a host I trust, this has the requirements I need from a customer perspective, and it does not allow the administrator to interact with the virtual machine. This does not stop on the disk layer. It also stops me from having this issue here. A customer is opening a virtual machine console. Like this. Oh, this is not possible here, but it's possible here. So the customer opened the virtual machine console, the administrator jumps in, the customer did forget to lock the console, I'm on the virtual machine with the credentials of the end user. Now how to protect from this? It's pretty easy. You just enable this feature on the virtual machine. Enable shielding. Shielded virtual machines are protected by default, if enabled, from the host administrator or the service provider admins. It can be controlled by the customer. So I can deploy a virtual machine from a shielded template, and it will be protected in this mode by default. Now, infrastructure as code is either PowerShell DSC. So you manage your hundreds or thousands of hosts, whatever, using PowerShell DSC to create configurations which are not only one-time applied, you create configurations which ensure that your systems are staying consistent all over the life cycle. Infrastructure as code that does not only mean PowerShell DSC. We also have a lot of automation runbooks in our deployments with our customers, where we try to automate everything from the beginning of a host setup. You want to deploy a new Hyper-V host. This must be a one-click or a one-command action. I don't want to install Hyper-V hosts by hand. And it doesn't stop there. We have a lot of runbooks we usually use for managing Hyper-V replica or managing storage enhancements or, let's say, storage actions we automate to free up, let's say, the administrators from going to the console and create a new volume. It can be ordered using a self-service portal or by just executing the right command. Azure Automation, of course, is a possibility to achieve this. If you don't have SMA, Service Management Automation infrastructure installed in your environment, it's a good way to go to Azure Automation and have those hybrid workers. So you create the runbooks on Azure, and the hybrid workers on premise execute the runbooks as you like this. You can have different run group worker, hybrid worker groups. So let's say for each region or each data center or each location, you create those hybrid workers which are going to execute your Azure Automation runbooks on premise. If we look at how to design a software-defined data center, not the only rule, but one rule of thumb is think in stamps. So you have a certain layer of power with your compute nodes, with your storage, with your scale unit, let's say like that. So just create a fabric stamp with some certain amount of storage and compute nodes and multiply it. Don't try to create a cluster with 64 nodes. Try to go to the max with your storage as long as you don't need that. Just create stamps also in terms of your stamp is going to be a failure domain. So a cluster with 64 nodes is still the cluster is a failure domain. It can fail. So we might create multiple clusters with, let's say, 8 or 12 nodes. Fault domains are an important thing. Not only the disks, of course, the rack can fail. So distribute your cluster nodes over different racks. If possible, distribute your compute or storage nodes over different aisles, or even rooms, if they're close enough and connected well together. Now, the point of protecting all this infrastructure from, let's say, rogue administrators or human errors can be achieved in different ways. So one way is the creation of Active Directory forests just for the fabric. So protect your fabric, your storage nodes, your compute nodes, using a dedicated AD forest. Don't create trusts to the AD forest. There's no need really to create trusts in your fabric. Prevent from having standard user accounts as accessing this fabric infrastructure. So don't use your usual credential where you are working on your desktop to manage the fabric. And separate logical from physical access. So if you look how Microsoft does this, the people who are working in the Microsoft data center, they don't have a knowledge or access to the services living in there. They don't have even knowledge which services are living on which part of the components. On the other hand, the operation stuff in the Microsoft operation centers, they never get physical access to the data center. That's an important thing if you are a service provider. You have really to configure to follow these policies to get your certification. Now, the last thing I want to show you is how do we granularly control access to this fabric components. Privileged identity management, privileged access management is a big issue because a lot of my customers also they do this by not by bad behaviors, but it's more comfortable to be domain admin, enterprise admin. I spread these permissions to all my people who are required to manage the fabric. But this introduces a huge issue. If something happens, if something breaks, who was it? In the best case, I can, let's say, trace it to the person who did that. But it might not be intentionally happen. So he just executed the wrong command because he didn't know it better. So, oh, crap, I did execute delete virtual machine for all of my VMs. But I don't need this command usually for my daily operations, for example. So one way to achieve this segregation of duty, let's say like that, is just enough administration. You might be heard of this capability from Jeffrey a lot of times. But if we look at the implementation right now, it's based on PowerShell. So it's a PowerShell only way. This also means that no GUI-related tool can leverage this configuration. So what we're talking about here is going to a remote machine using PowerShell remoting and execute those commands which are allowed to. So neither a virtual machine manager nor any other system center graphical user interface does allow me to have this JEA capability, to make that really clear here. So let's do a demonstration on JEA. In this example, I'm going to start a PowerShell console with my user John Doe, which is not a domain admin, neither a local server admin. And I want to enter an interactive PowerShell remote session to my Hyper-V node 02. Because I'm not locally administrated on this machine, I'm not allowed to do that. That's default behavior. Now, I don't want to be this user a. I can show you that this is user. It's John Doe, so I don't want to be this user local administrator. So how can I do that? Again, I'm going to using PowerShell DSC. PowerShell DSC has a module called JEA, and I don't want to bother you with the code here, but what I'm doing here is to create a new endpoint. In the toolkit VM ops, I'm defining which commandlets the user is going to be or going to need. So I define all the commandlets which he will have access to. Then I create an endpoint, and I apply this endpoint to my Hyper-V 02 node. I've already done this. And then if I've done this, I'm able to log into this remote computer. So why am I not able to log into this remote computer right now? Because I disabled the everyone access to this endpoint. So the second thing here is not only JEA, it's also just-in-time administration because of the fact I enabled this functionality on my forest. So I'm going to add John Doe to a Active Directory group named GA Hyper-V Operators. And if you see that, this is a new feature of Server 2016. I can limit the membership of the user for this group for a certain amount of time. So I'm going to add him to this group. And now if I do a get AD group, nobody's in there. Did they really execute this? Yeah, now it's in there. So he will be now a member. You can see the countdown here. He will be a member for the next 60 minutes within this group. So I'm going to start my PowerShell console again to get the new token. Otherwise, I would have to log off and log in again. What I'm doing here, I'm telling the PowerShell remoting to use the endpoint HyperOps because this is the one I created before. So now I'm able to log in to this physical computer, the Hyper-V host, using my John Doe administration credential. And if I go here and do a command like get process, I'm not allowed to do that. I'm allowed to do get VM because this is the command that I gave him in this endpoint configuration. So this is just enough admin and just in time admin because my Kerberos token for this remote session here will end within an hour because of this dynamic group membership. So, to end this topic, we have the organizational pitfalls. Usually, in large organizations, you have the network admin, the storage admin, the Windows Server admin, which doesn't care about storage at all. The network guys, they're always making failures. It's not my fault, it's always the network. And this is a huge issue. If you want to create a private cloud for whatever reason, if you are a service provider or not, you have to have a team which works together. And this is one thing I always see in larger projects with big customers. They have those segregated duties, and they live in those small boxes and don't care about the other stuff from the other people, which is a huge issue when everything becomes software defined. So the technical pitfalls, again, to summarize it: hardware jungle, tons of different components from different vendors, not standardized components following the OMI or REST API standards, lack of automation, and tons of different graphical interfaces to manage the infrastructure. Some of the stuff I've showed you here is from a project I'm currently working on with the Swiss service provider. The infrastructure I've shown you with the end user perspective of the software-defined networking. This is currently running in production. So just to prove that it's not only a lab stuff, right? I have 2 minutes for questions. Otherwise, I will be around for 1 or 2 hours until I have to catch the plane. Are there any questions? No questions. No, you don't have to log out. Well, you could list the k-list purge trick. I didn't want to show you that, but of course you can, if you are already logged in and somebody enables you to be a member of an Active Directory group like I did, you just execute k-list purge. And for all Kerberos-based services, like Windows WinRM is by default doing it, you will have a new token issuance then. So the TGT will be renewed when you do a k-list purge, and you get a new token as you log onto the remote system. So the group membership will be reapplied, or let's say reread, if you do a k-list purge. On the other hand, the TGT will expire, so anything you do on the remote system which requires authentication against a virtual machine manager, for example, or the Hyper-V machine service, will require you to be authenticated. So if the TGT is expired, you don't have access anymore. Yes?
When you were demonstrating the creating a software-defined storage share in VMM, I see that it automatically also named the cluster object for you, but did it also rename the CSV folder junction on the system disk to match?
No, unfortunately not. So this will be volume X, 9, 10, 11. As it's all done by VMM, I don't have to care about it. If I want to troubleshoot it, then yeah, that's a big question. So the question was, does VMM rename all the fancy stuff behind the scenes, the CSV volume mount point, the CSV virtual disk behind the scenes? No, it does not. It creates a random number and also a random volume mount point. Yeah, another question?
Yeah, with a hyper-converged system, is it supported to also create a scale-out file server cluster object so that you can serve storage up to standalone Hyper-V clusters?
It's technically possible. But as far as I know, the loopback, not the loopback, it's technically possible. But I'm not really sure if that is supported. I think it's not supported. It wasn't supported in TP5. If this changed, it might have been changed, but I don't think so. So having a hyper-converged system, in the meantime, serving the storage on the system for external Hyper-V clusters, I don't think that is supported.
I'm wondering because the guidance to set up a scale-out file server now so you can use set teaming is to install Hyper-V and not serve any VMs.
Yeah, it might be because of another issue or reason. NanoServer, all I showed you is running on NanoServer, by the way. NanoServer does not support teaming LBFO. So you have to use set on NanoServer, which means if you have a scale-out file server for storage space direct running on Nano, you cannot create teams. Otherwise, yeah, other than installing the Hyper-V role on the NanoServer, then you can use set, switch embedded teaming. But again, the question was if it's supported to have a hyperconverged system running maybe virtual machines and in the meantime serving SMB storage for other clusters. I'm not sure if that is supported. I can check that with the product team and get back to you if you want to leave your email address.
Sure, thank you.
Other questions? Yes? The question is, what are the requirements for using the storage quality of service? It's basically Server 2016. It does not work with 2012 R2 hosts. It doesn't have to be a scale-out file server based on 2016, neither a hyperconverged system. You can use a traditional, let's say, Hyper-V cluster running on Server 2016 with SAN storage underneath. That does work as well and is supported.
So the host has to be 2016?
Yes. Yes. Other question? Do you mind if I take one behind?
Quick one. How did you get the real-time IOPS in the web page when you were demonstrating?
Oh, this was just perfmon. I added some counters in perfmon, and then I exported the settings to an HTML file. That's basically what it was. Then you can open the HTML and press the play button, and it will show you the. It was just to have a better experience for viewing it on the screen rather than in the perfmon console.
So you have to build that, or is that part of perfmon?
It's built in, so you open perfmon, add some counters, right-click and say save settings as blah 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 HTML. That's basically it. There was another question.
Do you know if direct device assignment works in Nano?
Discrete device assignment. It should be supported. I've never tested, but it should be supported. Yes. Yeah. Yeah, no remote effects, because of the fact we don't have the full-blown core, the full-blown framework on Nano. Other question over there? Yes.
How are most customers managing this type of cloud environment? Are they using virtual machine manager mostly? What do you see out there?
Well, there are different. Yeah, the question is how do customers manage this type of infrastructure? VMM is one thing you have to have in large environments. Otherwise, there are no other tools than VMM to manage a large fabric. Or you create your own management layer using scripts or PowerShell-based GUIs by your own. But I would say VMM is a good tool to manage the fabric. So compute, storage, a bit of network also. Well, there are other tools, of course. Like 5.9 has a Hyper-V manager if you don't have VMM. But again, then you don't have this bare metal deployment feature for your hosts, which you're really going to need if you have hundreds of hosts. You want to automate the setup with bare metal deployment out of VMM. That's a good, cool feature. So I would say yes, most of my customers are using VMM to manage the fabric. One last question, yes? The question is for shielded VMs, is there a way to show the VM console to an administrator, right? No, there is no. If the VM is shielded, you never have access to the virtual machine console. And you also don't have access to the functionality of the integration services like the PowerShell Direct, of course. You don't have PowerShell Direct to the virtual machine if it's shielded. No, it's really protected. So with that, one last question, then I have to leave for the next speaker.
Does the customer that has the keys to the shielded VM, can they
if the customer has the key, does he? The question is, yeah, I got it. If the customer, that's correct. The customer has the keys to protect the virtual machine with shielded VMs. Is he able to see the console if he's going to Azure Pack, connected to the virtual machine using the console gateway connection? To be honest, I'm not sure. I would say no, because it's disabled by default. And as we are moving to Azure Stack, this console feature is completely going away. You don't have this on Azure.
But the administrator could then, the guy with the keys could then lower the level of encryption and then add access to console, right? That would probably be an option.
Yes, but your virtual machine won't start then. You can protect virtual machines from starting if it's not shielded anymore. So if the administrator tries to disable this, he can basically put it out of service, but he never has access to it.
You have to power it all, convert it to unshielded to bring it back up.
Good question. Good question. I have no answer. So to be honest here, this is a good question. I have no answer right now. So with that, I'm around for some minutes, but thank you very much for being here. Thanks.